last video covered parts of Chapter 2 and Chapter 4. This video we're going to jump into Chapter 5. Chapter 3, I don't know why they put it in the order that it does, but it requires a little bit more knowledge of how switches and how routers work before you can actually address it. It covers some stuff a little bit in depth, but it's kind of weird to be in the position that it is. So I'm going to talk about Chapter 5 first. So we're going to talk about the difference in broadcast, multicast, and unicast. So, right. So the first thing you need to know about switches is that they operate at layer 2 and they use frames. So we've discussed that in previous lessons. So we're actually going to log into this switch right here. And you can't see, it doesn't show the actual connections on the switch, but right now I've got a port connected to PC1, PC0, and PC2 in ports 1, 2, and 3. That's how ports are labeled on Cisco switches. The first port is port 1, the port underneath that one is 2, the top port will be 3, so all your odd ports are going to be on top and all your even ports are going to be on bottom. So we're actually going to go into the command line interface on here and we're going to type enable. And first we're just going to configure all of our access ports. So access ports are used for users, so end devices. So this PC, and this PC are all going to be access ports, and then trunk ports connect where they're sending multiple VLANs across. So that's going to be between these two switches because we're going to be setting up two different VLANs on these devices and then pinging across. So we've got switch 0 and switch 1, and on this interface here, which is the gigabit port, gig01, is where we're going to configure a trunk port. So first thing we need to do is we need to actually create the VLAN. So first thing once you get into enable mode, you type config T, and once you're in configuration mode, you type VLAN and then you type the number of that VLAN. So we're going to create two VLANs today, VLAN 10, and we're going to name this users 1, and then we're going to exit, and we're going to create a VLAN 20. We're going to name this one users 2. We're going to exit. So once you create your VLANs, you want to put them on individual ports. So I'm going to first go into interface, FA, which stands for fast Ethernet, 0/1. So this is the port 1 we were talking about. And I'm going to do switch port mode access. So this turns it into an access port. And then you want to tell it what VLAN that port is in. So switch port access and then VLAN 10. So we're going to put 1 and 2 are going to be in VLAN 10, and then port 3 is going to be in VLAN 20. So switch port mode access again, switch port access VLAN 10, and then finally we're going to interface FA03, and we're going to do one more time switch port mode access and switch port access VLAN 20. So we've already configured up all of the access ports, and you can see here that it's going from orange to green, and that's because there's something called spanning tree, and it's doing a basically a 15-second delay before it actually starts forwarding frames. And spanning tree is something we'll talk about later. The last thing we're going to configure is the trunk port. So I actually put this on the gigabit ports. So interface gigabit 0/1 and switch port mode trunk. And you can see that it changed state to down and then went back up. And that's because it's a different configuration from the other side. So now I'm going to log into switch 2, go into the CLI of this one. We're going to do the same thing on this side. We're going to config T, we're going to create VLAN 10, name users 1, and we're going to create VLAN 20, and we're going to name it users 2. Then we're going to go into the interface, FA01, and we're going to do switch port mode access. Switch port access VLAN 10 and interface FA02, switch port mode access, switch port access VLAN 10, and then finally 03, switch port mode access, switch port access VLAN 20. So we've configured up all of our ports. We just have to put IP addresses on all the devices now. So I'm going to go into PC1, which is, if you hover over here, it'll tell you what port it's connected to. Well, it should. These are finicky when it comes to this, but you can see I put this one on FA01. So 01 was in the 10 VLANs. We're going to config fast Ethernet, and we're going to do 192.168.10.1. Go to PC2. 192.168.10.2, And then finally we'll go into PC3, configure interface fast Ethernet 192.168.10. Or sorry, this one is in the 20, so 20.1. Alright, and on the other side, this one is connected to FA01, so config fast Ethernet 192.168.10.3. This one's to 02, so config interface 192.168.10.4. And then finally we'll configure our last PC, which is in the 20 VLAN, so 192.168.20.2. So now we're going to discuss the difference in broadcast, multicast, and unicast. So broadcast, whenever a frame needs to be sent to every single port, what it will do is it'll send it to every single port except for the port it came in on. So PC1 sends out information and it needs to be broadcast to everybody. It'll send out all that information through every single port except for the port it originates on. Unicast is where, let's say, PC1 knows about PC3, or sorry, the switches know about PC1 and PC3. So whenever you send information, if you ping across, the information will go to the switch, it'll send it over to switch 1, and then switch 1 will forward it to PC3. And no one else will be told about this connection. No one else knows that PC1 is sending information to PC3 because the information is only sent to a single address. Now, multicast addresses are when you need to send to multiple locations. So let's say you need to send it to PC0 and PC2, it would be a multicast address, and that's how it would go. Instead of going out to every single port, a multicast message would be sent to PC0 and PC2. So that's the difference between multicast, broadcast, and unicast. We'll talk about some situations where broadcast and unicast are used. We've already talked about one when you just need to ping across. That is an example. But when switches learn MAC addresses, logging synchronous. When switches learn MAC addresses, the way it learns is by, like we discussed before, the source address. So whenever PC1 pings to this PC over here, and we'll go ahead and do that. We'll go to desktop, command prompt, and we will ping 192.168.10.3. And you can see we're getting the pings because they've already been communicating with the switches for a little bit, and their information is in the switch. So no pings were dropped this time. So when we pinged across, the source MAC address, whenever it gets to switch 0, it would know, okay, so PC1's MAC address of, if we type ipconfig/all, we need a space. The switch 1's MAC address of, we are in switch 0. Okay, hold on one second. 4887, okay, is right here. So this MAC address, whenever it pings across, you noticed that it wasn't in this MAC address table before, but whenever we sent information, it noticed, oh, we've got a MAC address coming across. So whenever that source destination reached FA01, it added it to the MAC address table. So F4887 was added to the MAC address table, and that's done by learning the source address. If we look at switch 1, we can take a look at its MAC address table, and you can see that PC3 pinged back, right? Because I had to reply. So, MAC address last 4 of 4cc was added here. So the source MAC address is now being sent across, and the information has now been retrieved. Like I said in Packet Tracer, it's not going to show up like it would in the real world. It basically just operates differently in the real world. I mean, because that's why we're seeing something on FA03. It's probably been sending information that we just aren't aware of right now. But whenever we sent these pings across is when the MAC addresses were added into these tables, and that was done by adding the source MAC address into the table. So it's pretty straightforward on what a multicast is, but let's say you're trying to ping if the destination MAC address, so whenever you're trying to ping with this IP address, it's actually trying to reach this MAC address over here on the switches, because switches don't really pay attention to the IP addresses. They're more worried about the MAC addresses. So if you're trying to reach a destination that is unknown, so let's say a new PC popped up, PC5 over here, and PC1 tried to ping PC5, PC5 wouldn't respond because PC5 would be waiting for information, but these switches wouldn't have the MAC address in the table yet. So what they would do is they would send out a broadcast, and everything within the same VLAN, and if you check here, if we do a show VLAN, VLAN 10 right here is on ports FA01 and FA02. So any port that's in the same VLAN would receive that broadcast saying, hey, do you have this MAC address? Are you this person? And if it doesn't, and if it is, it would reply, and then the switch would say, oh, okay, now I know where PC5 is now. I know it's on port 05 over here, port 04, whichever one we connected it to. So that's how MAC addresses are learned at the actual switch level. So one more thing we're going to do is we're going to take a look at PC4. So PC4, if you do an IP config, you can see it's in the 20 network, while over here on PC1 it is in the 10 network. So if I try to ping 192.168.20.1, or sorry, 20.2, it's not going to work. And if I try to ping 192.168.10.1 from over here, it's also not going to work. And that's because these are layer 3 addresses. Layer 3 requires a router to get involved. So without a router, these devices cannot communicate with each other. So the way you would fix that is you would add a router, and then it would have a route to each, the 10 network and the 20 network. But since we're only using switches, which are layer 2, we're not able to do that. Let's see. So whenever a MAC address is trying to communicate with another device that it doesn't know about yet on the switch, it's called flooding. So whenever you send in a MAC address that is destined for an unknown location, it will, what's known as, flood all the other ports. It'll send it out to every single other port, which is where the broadcast involved. Broadcast, flooding, they're basically the same thing. Most of the other information, and if you take a look in the Chapter 5 book of the CCNA, it's just showing you a lot of diagrams and pictures and things like that of exactly what I'm showing you. So if you want to take a look, take some time, and I would definitely recommend reading through each chapter. The videos will help you, but you're definitely going to want to read through each chapter to actually get all of the information. There are different ways you can actually show the MAC address table. So since we did, for example, we did show MAC address table, but if you hit a question mark, you can actually look at either dynamically learned, statically learned, or interfaces. So whenever we type show MAC address table, the type is listed here. Dynamic means that it was learned automatically. And some information was sent from a port to a user, or sorry, some information from a user was sent into a port, and then that information was tracked here and then added to the MAC address table dynamically. You can configure MAC addresses statically if you would like, but most people won't do that. There's no real reason to actually go into a switch, at least in modern days. There might be some rare situations where you go in and you statically assign, hey, this MAC address is on port gig01. The other thing you can do is you can type interfaces, and you can look at the fast Ethernet interfaces, and we'll just look at fast Ethernet 01. So if you show fast Ethernet 01, it's already dropped off. And that's because the MAC address table has expired. I'm not sure exactly what the timer is before it needs to refresh MAC address table on Packet Tracer. I believe in the real world it's 15 minutes on devices, but these switches in Packet Tracer will operate differently from how real world ones are, because real world switches use what's known as ASICs, which are each individual port or a group of ports on a switch will have a hardware device that's actually tracking this information. This on a Packet Tracer is done through virtualization, so it's not exactly the same. So that's just a quick lesson on Chapter 5. This is pretty much most of the things that it covers. I definitely recommend reading each chapter whenever we go through a lesson so you can get the full grasp of all the information. But Next chapter we'll be moving into is 6, and then I will probably revert back to chapter 5, I believe, after chapter 6. So, and that's because we're going to take a look at different things you can do in the CLI, and then we'll take a look at chapter 3 to basically make it have a little bit more sense to it. So appreciate you watching. See you next time.